Random variables are used primarily in conducting research, surveys, studies, and experiment. It is also used in predicting possible outcomes of an election, finances, and many others. Guys, please watch this video for us to explore random variables as one of the topics in senior high school statistics and probability. We will continue after the intro. The objectives of this topic are: number 1, define a random variable; number 2, classify random variables as discrete or continuous; and number 3, find the values of a random variable. Let's proceed to the definition of terms. A variable is any information, attribute, characteristics, number, or quantity that describes a person, place, event, or thing, or idea that can be measured or counted. A variable can be qualitative or quantitative, and a quantitative variable can be either be discrete or continuous. A random variable is a function that associates a real number to its element in the sample space. It is a variable whose values are determined by chance. A discrete random variable is a set of possible outcomes which is countable. Mostly, this random variable represents countable data like number of defective chairs produced in a factory. A continuous random variable takes values on a continuous scale. Often, it represents measured data such as height, weight, temperature, and the likes. A sample space of an experiment or random trial is the set of all possible outcomes or results of that experiment. A sample space is usually denoted by uppercase letter and using set notation, and the possible ordered outcomes are listed as elements in the set. Let's have an examples of discrete random variables. First, the number of defective cell phones produced daily. Number 2, the number of female senior high school enrolled in one school year. The number of watermelon harvested this season. The number of deaths per day attributed to COVID-19. And last but not the least, the number of watching DepEd TV per day. Please take note, all the above mentioned data are all countable, so therefore they are discrete random variables. The next set of examples are for continuous random variables. Number 1, the length of travel time in going to school, the time to finish a certain self-learning module, the average amount of water consumption per household per month, the amount of paint utilized in making a school mural, and the weight of newborn babies in a hospital. Please take note, it takes values in a continuous scale. They don't have definite or exact measures. That's why they are called continuous random variables. And now let's proceed to the main course of this topic, finding the values of a random variable. Example 1, tossing 3 coins. Suppose 3 coins are tossed. Let y be the random variable representing the number of heads that occur. Find the values of the random variable y. First step to find the values of the random variable y is determine the sample space. Let h represent the head and t representing tail to occur. For the solution in number 1, the sample space of the experiment is y equals question mark. To find the sample space, we can do the tree diagram or the manual listing of all the possible outcomes of tossing 3 coins. The first coin can be head or tail. If the first coin is head, possible, the second coin is either head or tail also. If the first coin is tail, the second coin can be head or tail too. And possible, the third coin can be head or tail too. As you can see in the continuation of the tree diagram of tossing 3 coins. From the tree diagram, we will determine the sample space by listing all the possible outcomes in order. The first possible outcomes of tossing 3 coins is all are heads. The second is 2 heads and 1 tail on the third coin. The third is also 2 heads and a tail on the second coin. And the fourth is 1 head and 2 tails. The next outcome is another 2 heads and a tail on the first coin. Next is 2 tails and a head on the second coin. The next is 2 tails and a head on the third coin. And the last outcome is 3 tails. After finding the sample space, let us count the number of heads in each outcome in the sample space and assign a number to this outcome. Let's draw 2 columns. The first column for possible outcomes and the second column for the value of the random variable y, or the number of heads. On the first outcome, we have 3 heads, 2 heads on the second and third outcome, 1 head for the fourth outcome, another 2 heads on the fifth outcome, 1 head for the sixth and seventh outcomes, and no head on the eighth and last outcome. Now, through counting the number of heads to all outcomes, therefore, the possible values of the random variable y equals 0, 1, 2, and 3. Next, example 2. A shipment of 4 desktop computers has a possibility that 2 are slightly defective. Let D and N represent the defective and non-defective respectively. Find the values of the random variable R purchased that are slightly defective. In this problem, let us list the sample space in order. The first outcome is 4 non-defective computers. The next 4 outcomes have 3 non-defective and 1 defective computers. On the fourth, the third, the second, and the first computer respectively. And the next 5 outcomes have 2 non-defective and 2 defective computers on different positions of defective computers from first to last. If you will notice, we started listing all the possible outcomes from 0 defective computers up to 2 defective computers. Let's proceed now to step 2. Let us count the number of slightly defective computers in each outcome in the sample space and assign the number to this outcome. On the first outcome, we have 0 defective computer. On the second, third, fourth, and fifth outcomes, we have 1 defective computer found on the different orders of the computers. On the 6th, 7th, 8th, 9th, and 10th outcomes, we have 2 defective computers found on the different orders of the 4 computers. After counting all the possible slightly defective computers in all the outcomes, therefore we can say that the possible values of the random variable are equals 0, 1, and 2. Third and last example on this video. 2 balls are drawn in succession from a box without replacement, containing 4 red balls and 5 blue balls. Let R and B represent the red and blue balls respectively. Find the value for the random variable M representing the blue balls. In step 1, let us determine the sample space for the random variable M by listing all the possible outcomes. To illustrate how the balls are drawn on the box, let us write 4 R's and 5 B's on the left box. The first possible outcomes, you will draw 2 red balls, so let us cancel 2 R's on the box. Second outcome is 1 red and 1 blue ball, so cancel 1 R and 1 B at the box. The third outcome is 1 blue and 1 red, so cancel 1 B and 1 R at the box. Since the remaining 3 balls are blue balls, then you will draw 2 balls and cancel at the box again. And just because only 1 ball is remaining, so therefore, double blue balls is the last outcome. Let us again proceed to step 2 by counting the blue balls in each outcome in the sample space and assign number to each of the outcome. The first outcome has 0 blue ball, the second and third outcome has 1 blue ball each, and the fourth and last outcome has 2 blue balls. Once again, on this particular problem, the possible values of the random variable m representing the blue balls are 0, 1, and 2. Again, I hope na nakatulong sa inyo ang video na ito, at kung bago ka pa lang sa aking channel, huwag kalimutang mag-subscribe at i-share mo na rin ang aking video sa iba.